Hello, this is Vidura. I want to make an update of the solid state generator with opposing magnetic fields. In the first test series there was a couple of wires crossed over, so it didn't match with the posted schematics. So here this is the setup now corrected. The diodes are connected in the form that the coils will have two opposite south poles in the middle of the ferrite rod. Then I have added here a small toroid to measure the current from the resonant tank circuit, and I have a 20 nanofarad ceramic capacitor as tank capacitor. Coil, pickup coil, and as load I have the 20 watt 12 volt bulb connected with a current probe resistor on it, and it is fed directly with the signal generator. It's set in 20 volts. Now we will scroll through the frequency. Here in the scope I will show you, I have the upper traces are input primary current, primary voltage, secondary current and secondary voltage. So we will scroll through the frequency to see the effect. We go up. We'll set the scope. We'll see to get the resonance frequency, which is a lot higher. Now we are near 300 kilohertz. You see it goes up. Yes, we are very close. I think it's about here is the resonant point. We'll go down a little bit with the current probe. Okay. You can see the current and voltage from the resonant tank circuit seems to be in phase. And we have on the output a triangular waveform, which is quite strange. I have never seen this type of waveform. You see current and voltage matches, but we have a phase shifting relative to the primary, I think. We'll bring up the voltage. Yes, here we have, you can see there is a phase shifting between primary and secondary. Do the same with the current. The current signal is not very high, but there is also some shifting there. Okay, you can see here the resonant frequency is 364 kilohertz. The output coil is loaded. It's not a lot of output, but it is in the 5 volt range, so we have about 10 volt, 9 volt peak to peak and the output loaded. The current is in 0.1 about 300 milliamps of current peak to peak on the output. Now I am trying with a small inductor to test the perpendicular field. I will put it in the middle first. You see, this is the center position, the trace, the lower trace. When I move it to one side, you can see it becomes much higher. There are nodes, now it becomes very much higher. I will change the probe to 1 to 10 range, because it goes very high at this point. So here from on the outer side of this is on the end of the ferrite, there is a maximum in the perpendicular field. Then there is at one point a reversal. Here we come to the center again. Now to the other side. And the other top. There is a maximum. I'm all the time in a perpendicular position with the inductor. You can see here is the maximum and here is another maximum point at the, right at the top of the inductor of the ferrite rod. Note that without the secondary coil, the resonant frequency went down to 306 kilohertz, from about 360 nearly with the output coil over the ferrite rod. So now I have changed the secondary for this setup of small ferrite cores, which are coupled in series. So this is the trace below. It is now exactly in the center, and I have 5 volt per division. The resonant frequency went down. It is dependent on the secondary coil, evidently. Now I've got 304 kilohertz, and you will see if I move the coils to one side or the other, the output waveform changes. I go to the other side. When I come near the windings or directly over the windings, I have much more voltage, about 15 volt or more peak to peak. This is in this position now. Okay, that's it for now. Further tests will follow. Thanks for watching.